All right, so for those of you who actually read the section like you were told to on Friday, it was clearly about igneous rocks. Well, what does that mean? I guess first let me ask you, this should be a grade school question. What are the three categories of rocks? No. Metamorphic. Sedimentary. Igneous is on the board. Igneous. Alright, so we got igneous, sedimentary, and metamorphic. And we're going to talk about all three of those here. Eventually throughout the week. By the way, your final exam is next week. I'm not sure if you guys are aware of that.
My final exam.
Yep.
What? The final exam.
And I can for term one. Yeah. Alright, so guys, what is, hey, focus please. What does igneous mean? What does that mean?
When the rock is formed
from lava, yeah. It's basically, they're fire rocks. Think about the word ignite. So ignite. Okay, that means to catch on fire, right?
Let's stand this.
Guys, come on. So when we think about igneous, it basically means from fire. And so all of your igneous rocks are basically rocks that are born from fire. And that fire is in the form of either lava or magma. So when you're asking, what's a good definition for igneous rocks? It's rocks that are from cooling magma or lava. Well, what's the difference there between the two? Can we use them interchangeably? Well, so what do you think?
Wait, what was the question?
What's the difference between magma and lava?
Okay, lava is above ground, magma is below ground.
That's perfect. So your lava is when it comes out onto the ground. And then the magma is below the ground. That's the only difference between them. Lava is once it reaches the surface, magma is underneath the surface. So let me ask you guys a question. Let's say I just baked a pie. Baked a really good apple pie. Nothing better than an apple pie. But it's too hot to eat right out of the oven, right? Right. So what do you need to let it do? Cool. Let it cool, okay? So let's suppose I want to try two different things. I let it cool by putting it by the window or effectively putting it outside. Or I simply turn off the oven and shove it back in the oven to cool off.
Burn.
Go, Chris. Go farther on that.
The oven will still be hot. It won't cool down immediately, so it'll burn the pot.
Okay, exactly. So which one would take longer to cool?
The oven.
The oven, right? Because it's still got this warm, insulating air inside the oven, right?
Yeah.
Okay. So, but if I put it outside, which is much cooler than the pie itself, what happens to its cooling rate? Yeah, it cools at a much faster rate. Well, guys, that's how we break igneous rocks down into extrusive and intrusive types of rocks. And you guys have seen these before. You've seen the olivine, and you've seen the obsidian. And from the two pictures, what can you tell me about their crystal sizes?
Small.
The ones, which ones are smaller?
Intrusive. Yeah.
If the obsidian is your extrusive, and intrusive is over here with the olivine, which one of these has much larger crystals or grain sizes? There, which minerals can you see easier? Which one's these? So the intrusive. Okay. So we get larger, so you guys need to write this down. We talk about extrusive versus intrusive. We get much larger mineral grains with intrusive rocks.
So this was
almost like a flash freeze. That was lava.
Mm-hmm. So guys, again, if you want a good definition, extrusive is where we're cooling outside the Earth. So we're cooling out on the surface. Intrusive is when we cool on the inside. So we have this nice insulation. Now, if you guys remember from our last part of this unit, we talked about minerals. What are the two things that minerals need in order to grow? Space and time. So, I have this lava, and I have magma. They're coming from the same source, which is kind of important to know. The lava sitting up on the ground, the magma sitting under the ground. Which one cools faster? Faster.
Oh, above the ground.
Above the ground. So the lava's going to cool faster than the magma, right? Okay, now this is really important. Try to follow me on this. So if I'm cooling faster on the surface, do my minerals have time to grow?
No.
No. So when we talk about extrusive and intrusive, one of the biggest ways to tell them apart is looking at their grain sizes. So with your extrusive rocks, we tend to have small grains. Small or fine grain. Which one? The black one is called obsidian. Okay. Perfect example of that right here is the obsidian. And in fact, when you look at that, you can't even see the grains. That's because there are no grains. Obsidian cools so rapidly that the grains don't even have time to create a mineral structure. And so you get this kind of glassy look to it. Now, however, when we look at intrusive, you can honestly see, I mean, even from the back of the room, you can see how large these minerals are and the crystals that are with the minerals. That's typical of an intrusive, where we have very large grained minerals. Large grained minerals. Move forward to this. And so, I mean, this is kind of going back to what we've already been talking about before, just really kind of driving this home, where if you have the magma that starts to cool, these are going to be your intrusive igneous. And then you can see out here we have the lava that starts to cool, and that's going to be your extrusive. So let's take a look at a geode.
Whoa. That is sweet. I want to go in there.
That's about 125 degrees ambient temperature.
It's fine with me. I think that'd be pretty sick.
That'd be sweet.
Yeah, dude.
Then I get
Real sick, guys.
Oh.
Alright, gentlemen.
Please punch him. in the
Alright,
face.
so, geodes. Intrusive or extrusive?
Extrusive.
No,
Because we're talking about the outside of the rock.
Now we're talking about the crystals on the inside. If the crystals have time to grow, what type of rock is it? It's intrusive. Alright, and then we can see that. In fact, this is what we talked about earlier. With this one right here, we're talking about how geodes form. Yeah. Basically, when we look at how geodes are formed, you have a ball of lava. I mean, you guys have definitely seen this before in images from Hawaii. We have the lava coming in, and it comes in contact with the water. So what does it do as soon as it comes in contact with the water? Yeah, immediately that outer edge solidifies, just like the cheese. Remember we were talking about cheese in the pan before? Warming up the cheese, melting it, and that top starts to kind of get that crusty look to it. What's going to happen is this lava, as soon as it comes in contact with the water, it instantly, on the outside, we instantly become crusty on our outside. And that creates a protective shell. That's what this is right here. We look at all this around. That's that crusty layer cooling very rapidly. What's going on right here on the inside, though?
It looks like an oven mitt that's on fire.
Okay, it's cooling very slowly. So what happens then is we can get these crystals that start to form. We get really large crystals, and the longer that a geode is able to form, the better crystals we get. And sometimes with geodes, the one I'm passing around right now is an open cavity geode. Other times, they're either solid or near solid. And they're kind of neat. And this is a perfect example where you can see the ball of lava gets completely solidified.
How much money do you think was spent on blocks?
A lot. Now, let me ask you guys this. So we talked a lot about today about magma. Well, what is magma? What is it made out of?